Okay, welcome back, everyone. Left everything as we left off, except for I was stalling on this, because, basically I had a little jerry rig that worked okay. Basically, I just bolted that to the inside of the frame, obviously with a 300 height would be like that, 350 like that, but it was hard to adjust and I didn't like it much. And so like this morning, well, between last night and this morning, I guess I did some messing around. So it's 3 prints. There's one of them. And I put that on, basically it's a knob. And then we have this piece that slides. That's a M6 nut by 1.0 pitch. And same pitch on the bolt. And it's 45 millimeters long, so M6 by 45 by 1.0. It's just a plain flat washer, slid down over, right, and I just pressed that into that'll go in a little firm. I was able to do it just with my thumb, and then the other things we'll need for one of the pulleys, we're gonna have 2 M5 washers. This is a GT2 toothed idler in 16 tooth. I think that's an M. Let me see if I can find my. Okay, so that's a M5 by 30. So one of them has to have this peanut style head. The other one doesn't really matter. And then this is the other pulley. It's bigger. It's a GT2 20 tooth, but smooth, meaning no teeth. And then we need 2 washers for that one, a regular M5 nut, and then a lock nut. And so I'm gonna kind of pause the camera for a minute, kind of get set up. And then before I do that, I might as well show the other part of what we're gonna do. So this is the plate. I just kind of overhung it on the bench, lined it up. It's designed and cut, the ones I have, like a little bit longer than you technically need. And the reason why this is because, see, this is our front and back with the linear rods. So up here, if you were to accidentally take the line or leave the line, depending on where you measured it, you could be like a millimeter long, a millimeter short, and it could even be a little less or a little more than that. So that's why I like to mark my whole plate when I pull it off, so that front, top, back, top. And then I put an X on these. I'm actually going to edit these so those holes won't be there, because where this is a sliding deal, obviously, well, your original Ender 3 bed mounted on one of these, and as you slide this and this, in the last video we did to get these adjusted and so that there was no bind, it changes the distance of those. So I'm either gonna go one step further than that. Doesn't matter if you drill this hole or this hole, but I'm only gonna drill one of them, and I'm gonna leave some of the white coating. I'm gonna take it off around the bearings. We'll leave the white coating on until we have it mounted on our rods and all of our rods hooked up. It's sliding smooth, and I'll probably poke the one on the left just because I'm left-handed. And what I'm gonna end up doing is, like I'll say, I'll probably start on this end because I flushed one end totally, and that's the front. The reason why is because them bearings, when they drop down in, will be flush with this edge, and it just looks better having it in the front. It doesn't really matter. It's not that big of a difference, and it doesn't affect the way anything works if it's turned around. But so what I'll end up doing is I'm gonna thread my holes. If you thread them, you're gonna drill them with a 2.5 millimeter, and then you're gonna tap them. If you aren't gonna thread them and you're just gonna use M3s with locking nuts, then I drill them 3.5 millimeter. That way they'll slide in and not bind up any. And then when you tighten them, it'll take up that little 0.5 millimeter jiggle. It'll actually probably make it easier to, if you have any binding, to be able to loosen the screws and jiggle stuff a little bit and get it kind of moving a little smoother. I've never had an issue with that. And so I'll explain this better when we're drilling this part. But let's get to this thing, because I also figured out a better way of doing the rest of the assembly. And then it'll just be easier to put in now. So I'm gonna pause the video, put it on a tripod, adjust things up, and then we'll get things on the road here. Okay, and we're back from the little break. So basically, this is our tensioner body. It's mounted right down here, and it goes together the same way, no matter if you got 300 Z height or 350 Z height. But the difference will be 300. It's going to be mounted this way with both pulleys up, so that when you look down at it, you'll just be able to see them. Now, if you're doing 350 height with the 400 millimeter lead screws, instead of mounting it so you can see the pulleys, the full pulley looking at it, it'll be mounted like that and still over somewhere in here. And so what we're going to do is you're going to take this piece and the M6 by 1.0 pitch nut, push it into the hole, and it's going to slide into this slot with the nut pointed back towards the opening. You can just slide it in there a little ways, And this is the M6 by 45 1.0 pitch. It'll fit in the knot a little bit into the knob a little bit snugly. So I just kind of like took this washer, slid it down on, and found me a little 1/4-inch drive socket, and just kind of very light little taps, slid it on. Now we're going to leave that washer because it's going to go on the front of here and just kind of, oh, it's not really a bearing, but so that's going to go in the hole. And then you're just going to thread this in till it's sticking out of the knot a little bit. And, oh, whoops. Let's backtrack a little bit. Getting ahead of things here. So, remember I told you about the nut, the one bolt that has to be like this. I think this is a 35. We'll check to be sure. Maybe a 25. No. Okay, it's M5 by 30. And you can probably get away with M5 by 25, and you'll see when I put this together that the bolt does stick out a little ways when it's done. It's not real bad. I got the 400Z, and I don't feel like cutting the bolt, and I don't want to wait for something to come on Amazon. So anyways, this fits in this hole slightly, not like tight, but it'll kind of thread in. And the reason why this matters is because, you know, the head is because if you use this style head, the head will be kind of like up in the edge of that hole in the front, and you won't be able to get the M6 bolt to go through. So anyways, once that's on, again, the nut goes to the back, slide it in, get it started into the nut, and then the small pulley is we're going to need this M5 by 30 and 2 flat washers. And so these flat washers, if you remember from the video before, have a rounded edge and kind of a more sharp edge. And we're going to put it on with the more sharp edge on the top of the head, so it's, and then we're going to slide our bearing on. And the reason why that washes that way is because if the bevel was the other way, it would want to kind of rub a little bit. So again, the rounded edge towards the bearing, the second washer. And this is going to go in that bump out with the hole. And what I do, I didn't bother to put an insert because I made the hole so that unless you take this apart like 2 dozen times, it's never going to back out. We're going to thread it in. When we get close, what you want to do, it'll be pretty much flush with this back, or just about. So we don't want to have a lot of jiggle, but we don't want it to be like tight either, because tight, and see how I can't spin my pulley. So we're going to back that off till we can just spin it freely. And you might feel like just barely a little bit of play there. That'll be good. And we're just below flush here. So now we need the other pulley. Oh, and this is the 16 tooth GT2 idler. This is the 22 smooth. We're gonna need that. Again, 2 washers. They go in the same pattern. So we want the rounded side up because the bearing's gonna drop on, and rounded side down. I hope I'm in focus doing this. And then we're going to take our regular nut, not the locking nut, and we're going to thread it on. And you'll notice if you go all the way hand tight, you can still turn it and whatnot, but you can feel a little tiny bit of drag. It's got a bearing in there, but it's hard to find a washer that's totally perfectly sized for this application. So this is the lock nut. What I usually do, just because it makes it easier to not loosen up, I just kind of give that a little bit of extra, just so that it doesn't spin a lot. And then I wind this one close, and we're going to adjust this one. And this is what I mean by, I could have used a slightly shorter bolt. It's probably about 5. Whoops. So I can still turn that, but we get some drag, and we can't have the drag. So all my wrenches are too wide, except for these cheapies that come with the mod parts. So now I'm going to back this off a little bit till it just turns, and then I'm going to tighten that lock nut to it, holding it. And then you got to double check after to make sure that this turns nicely. It's okay if it wiggles a little tiny bit. It's not going to affect anything. I can just barely feel a tiny bit of up and down play, and you want to lock those fairly tight. And the 350Z goes down like that. The other Z, the 300 height with stock lead screws, goes like that. Now, so basically, just so you can see what I'm doing, because I did this as the 350, I am going to also build another one of these in like hopefully a week or so. And I'm going to show both ways. I'm just flipping this over so you can see it. I don't usually flip it over when I do this, because I can pretty much do it either way. So, make sure I'm in focus here. So now we're in a different area. Okay, so I like to have my adjuster closer to my motor. So what I'm going to do is I'm going to turn my nuts like that, the T-nuts, the M3s. And another thing that you're going to have, and it's because of the bump out, see how the tip of this Allen wrench has like a little ball type feature? It'll help you get in there and tighten that one up. So it's easier. Whoops. What I'm going to do is I'm just going to set it anywhere on the frame. It's easier to get to this one first. So we're going to turn this just kind of till it spins, locks, and gives a little bit of friction, but can still be slid. And let's see if I can get in on this back one. I'm going to do the same thing in the back. so I can still slide that. So coming from the motor side, we're going to go around the tooth pulley on the outside, and then we're going to go behind. I guess I'll pull it off to show you. So this is your motor in the back. We're going to come around that small pulley. Well, camera's rotating here. With the teeth. Back around. So now as we slide it this way, we're going to lose some of the slack, which is a good thing. And then let me see here. So basically, I can get my adjustment. You just want to push it back. I like to pull this way, push it up till it's taut, and then go just, like basically, pull this out like that kind of, and then just go slide it till the belt's taut, and then tighten these. And then you'll have, some adjustment area left over. You could slide it back more, but I don't really want to get it way back. This is a 1,000mm belt. If I did it again, I'd probably use a 990. And the only thing is, like if you want this way back, then, it'll grip any way you look at it. The big thing is you got to make sure you have clearance right in there with how far back you go. And as long as you got clearance, it'll work just fine. And if you go with a 990, you just won't be able to slide this as far that way. And I'm not sure exactly how short you can go. Because I just happen to have a bunch of these 1,000mm loop belts, and I discovered that I could use it, so I just did. And I'm gonna put it back on the little mount here because I gotta get this harder to get bolt at that angle there. And so you don't want to crank these to the point where you break them or crack something. It's just plastic, but you do want to go enough so that it's going to hold. And then after they're tight, you can just adjust up your belt and it was hard to even get it that tight with my other assembly. And so there you have it. That's the Z-belt. Obviously, this is flipped over so you can see it. And if anybody has any questions on the 300 height style with this piece, built the same but flipped over, it's basically the same deal. You go around this tooth pulley first, back around this one, and I probably would recommend the 990 belt just because you'll be a little bit this way, and I got plenty of adjustment. I'll never need more because by the time the belt stretches that much, it's going to be broke anyway. But I do like to see a little bit more, just so that I know that I'm not going to have an issue or too big of an angle. So I'm going to put this back over and got a bunch of stuff here. Okay, so now when I turn one of these, I don't know if you can see what I'm doing. Like if I turn one of these, both of them turn. You do kind of want to, I wouldn't have stuff hooked to your board. It's not real good for it to move because these generate power, or that generates power. This isn't a stepper, but I like to turn them a few turns both ways, just so I can feel if there's anything catching or binding. And usually if you feel something catching or binding, it's because one of these screws is too tight, and it'll make that belt kind of go a little dry, and it might even jump teeth if it's too tight. So that's the belt adjustment, and pretty much the rest of the Z. I mean, technically we got the bolts go through there. I actually run this machine a month and a half with no bolts in any of them, and because they don't really have to be held real firm. You're lubing the bearings, and nothing's like moving right back and forth aggressively. I mean, you might have Z-hop, but and I mean, I would put the bolts in. I just didn't have any at the time, and I also had all my printers go down and needed parts, so this was doable that way. So now I'm gonna pause the video, get set up for this template and drilling, and then we'll drill that, drop the bearings in, and we'll be down so that what we have left of the physical build after that will be our Y-axis, our X-axis, and then, like our extruder motor, and or in my case I got a direct drive, but I am gonna kind of show a little bit about the factory extruder. It all fits, and there's two ways to do the Y. One of them is like an identical clone to an NFI. Well, not quite identical, because in plastic it's got to be double plated. I'll show what I mean in the next video. But alright, so let's take a little intermission, and I'll be right back. Okay, and we're back. So basically, this is our template. It's the first time I've used the template. I mean, I used pieces of it before, but I did it a different way. And of course, figured a way around the flaw, but I'm just going to fix it tomorrow in the files, so that you won't have to worry about this, but I'm going to explain it. So anyways, we had nuts on the backside, and they hit, and so I ended up making a lot of marks, and then I kind of took a very sharp awl and just kind of made some little scratch spots on the plastic so that I could take the nuts off the back after I flushed and clamped one end. And then I kind of laid it out as good as I could, spun the nuts off the back after I also measured. But what I'm gonna do to fix that issue is I'm gonna widen the area here to go out past the plate with the adjustable bolts, and that way you don't ever have to loosen them. Nothing gets in the way. You just know it's where it needs to be. I actually spent like an hour making sure that this was where I wanted it, because I don't want to drill and have a problem and then have to make a whole new plate again. So anyways, just to show you. The underside, I used some scrap prints to kind of protect the surface, even though it's coated. It's an aluminum plate. This plate is 8 inches by 16, which is, I guess, 406 millimeters by 203. And that's also why this is printed in 3 pieces plus the sliding. So what we're going to do, there's 2 ways to put in these linear bearings. You can either drill a 2.5 millimeter hole, which is what I'm going to do. This is just a cheap drill bit kit that I got from Harbor Freight. Or actually, maybe I got this from Amazon, I guess. But it's just a cheap drill bit kit. Done quite a few open builds with these. We're going to drill 1 hole in the corner, like we're overhanging this so it can be flat, so we don't drill through the bench. I'm going to drill 1 hole. You kind of want to try to be level if you can. If you have a drill press, which I do, but it's not in a great area for videoing. So I'm going to tap my hole right now. You can use nuts. When I use nuts, I use a 3.5 millimeter drill bit. But if you're going to tap them, which is the way they're done on an Ender 5, this is an M3 by 0.5 thread pitch. And I'm not going to load it with 3-in-1. We just need something for cutting oil. Just going to try to get like drop or 2. I guess I did kind of load it. It doesn't have to be. I usually just kind of try not to have it too heavily oiled. And we're just going to take this, set it down into our hole. And there's a reason why I'm doing this. I got to get it started a little bit. We're going to work this like this because this is a small tap. And if we go too many turns, we're going to build up aluminum in those slots. It's going to bind up when we go to back out. It probably wouldn't in this thickness, but like thick stuff it definitely does, and I've broken a tap. So it's, you know, you're going to do quite a few holes. So I go like half a turn, a little over, go back the other way, and I do that till I'm satisfied. Like you'll kind of feel it turn a little easier in both ways, and then you can just back it out. One of the reasons why I'm doing this is because even though I'm held with these vice grips, I'm drilling, you know, it's possible that I could slip, bind up, something to that effect, and shift this plate. And if you get 2 or 3 holes drilled and you shift that plate and got to line everything back up, it's much harder to get your bolt holes like totally true and have a, well, it's probably impossible to be totally perfect, but near perfect gantry. And just using them 3 by 8s. You could probably even use 5s. I like them to stick down a little bit past the bearing. So we're going to thread this one in. And when it gets snug, We're gonna go a little extra so it's got a nice firm bite. And now we're gonna skip over to the opposite side, and we're gonna drill that one. Try to keep level. You don't want to drill it at like sharp angle, because then your bolts are gonna be pretty crooked. Like the drill press is the way to get it 100%. But okay, so down through, and I'm not gonna move it this time. I do it like every 2 or 3 holes. If I was doing a bigger size and thicker metal, so gonna 1/2 to 3/4 turns, go back and forth. That way we don't have that aluminum build up in the threads. And you probably, what I do, I don't bother to put in all the bolts while I'm drilling this, but I like to do a cross. So I'll hit probably this hole next, and then this hole, lock them up the same way. And this is the front, that's going to be the front face. So we're not going to drill either of these 2 holes. I'm going to make those disappear in the final design tomorrow, so that you ain't going to worry about that either. And then I'll also have a little print just in case you don't have a stock gantry anymore. Meaning this piece here for a drill template. If you don't have that, it won't be a big deal, because I got a 3D printable one of these, and it doesn't have to be this thick. I'm probably only going to make it like 1.5 millimeters, 2 millimeters. That way you don't have to waste a lot of plastic. And because it's literally going to be there just to drill some holes. So you got to put another screw in. Right now I guess as long as they're threaded all the way down, they don't go past the bearings, it's a good length, it'll work. So that locks that up. And I don't know, I've done this without locking them up before. Sometimes I have to kind of re-drill the hole and wiggle my drill bit a little bit after. So I'd much rather clamp them down, not have any sliding around. Bolt bin over here, and another little drop of 3-in-1 on the tap. Just kind of give it a little shake. Sometimes I use my fingers and give it a little pull type wipe. And after you get like 3 or 4 in, it's really not going to go anywhere. So you could probably just tap 3 or 4 of these and then drill them all and tap them after, or you can use nuts like I said, but you're going to use a bigger drill bit. And one other thing that I did, You get a little brass nut where the lead screw goes. They make a few different styles of those. Some of them are 2-bolt, some of them are 4-bolt. Just because, well, I only put 2 bolts in, and I use lock nuts, and I use a lock washer on the top side, and I tighten them up till it kind of sinks that lock washer about halfway. And I do that because then if the lead isn't cut perfect, and they never really are, this nut won't like have up and down play, but it'll still be able to just barely shift, and it'll cut down on things like weird Z noises, Z banding, different things like that. And so I'm going to drill my other one. And the less you're overhanging your bench, the easier it is to drill the hole. And I've also found that there's kind of a sweet spot for speed drilling aluminum. So if you get a real fast drill, you're going to find that wide open is not the way to drill it. I guess I might as well tap that one too. Where did it do with the tap? And then after this, the rest of them, I'm just going to drill them all. Well, the other end will have to do the same thing. And I may pause the video to finish drilling this end. Well, I'll drill the weeds, or at least one of them. I mean, they drill the same way. Same size drill bit, same size screws. And so I got 2 tapped holes here. What I like about this way is I don't really have a nut to loosen up. I mean, I was thinking about putting a nut on the underside anyway, because these you don't want to loosen up. Okay, so we know this isn't going to shift unless we like beat it with a maul or something, and then it's pretty much no good anyway. So I'm going to poke these 2 holes on camera, and then I'll end up pausing the video, flipping stuff around, getting set up. We'll do the same thing on the other side, but we're going to poke 1 extra hole, which will either be this one or this one. I'm not going to poke the others, because what I'm going to do is I'm going to mount this in, get it where I want it, and I'm going to measure from the center of this hole to the inside edge of the rail, and then I'm going to make a square line at that, from the hole, and then that way my bed, if for some reason we was off like a 0.5 millimeter or a millimeter, we'll still have a perfectly skewed bed this way. And it should be in theory anyway, but I just like to be extra sure. I mean, a millimeter skew probably isn't that bad. You'd end up running like 233 or 234 and be able to to do a full print, but like your purge line might be half off the bed if you're skewed, and I like to have them pretty primo. And we're not going to drill the big holes yet. We're going to be marking some stuff out. And man, it looks like I'm probably going to have to charge my darn battery. And I always drill the front to back one. You can drill left to right. You can drill all four of them, but it's beneficial not to. I'm going to pause the video. I got 6 more holes on that end to do and tap. You've pretty much seen how it's done, so it's kind of crazy to add an extra 10 minutes to the video, so we'll be right back in a few minutes. Okay, we're back. Basically, during the break, I finished drilling all the holes here. I did decide to drill all 4 holes here. One of the reasons why is because even though I'm only going to use 2, I figured it's easier to get a reference for center that way, because we're going to blow all the dust off from the drilling after we're all said and done. And because our jig will break and different stuff, plus when you got a 3/4/19mm drill bit, like starting a hole and not having a pilot hole, I think this is like a size down from the max, but I think the other one's over there. What you're going to have for a problem is you can't really line that up in the center. And not only that, but you get kind of a nasty hole if you just kind of start at max size. So, after we're all drilled and we got, 2 bolts here, 2 bolts here, but up there and everything drilled, we got 2 different kinds of Sharpies here. You can see this one here has a real fine tip, and that's what we're going to want. Wrong cap. Over this, because if we, trace out our circle, and that's only to help us kind of get center a little bit, this is not going to get tight into the edges. And you might be able to do it without that, but the circle is kind of an extra, just to kind of more measure points you can double check before you take in center punch. Because now this is a center punch. It's been beat on a little bit, so I had to kind of touch it up. But they're not like sharp at the tip, but they're not real blunt either. They're kind of in between. And what these do is, once you find center, you'll take and put it on your material right where your center is, and you take a hammer, just a little tunk. It doesn't take a lot because it's aluminum. We're just looking to make a little divot, and then you'll start with a small drill bit, like either 2.5, 3 millimeter, and poke the center of the hole. We're going to do it this one, but we're going to do some finish poking holes, tapping, just like we did before. I drilled one hole off camera Gonna drip a little drop. I'm only gonna do 2 of these on camera because, you know, there's no sense to have a 2.5, 3-hour video or something. And so I'm gonna get it started, and then again, 1/2, 3/4 turns. And we're gonna back off in between the turns. And when the threads are cut all the way, because this has a slight taper at the beginning to help get it started, this will suddenly turn easier like that, and we get a nice threaded hole there. And we're going to drop a screw right in there because we don't want the risk of sliding around for the next hole and the ones after. And just gotta grab a couple of screws here. Oh, got one shorter one because my container's mixed up a little. It's always nice when you drop a fresh pack of screws. Some of them kind of get into the divider next to it. So we're going to bring this down till it's snug and then give it a nice little twist. And my battery went dead on me, so I'm using an old yard sale Black & Decker kind of beater drill. Going a lot faster than it needs to be, so I'm just kind of hitting the trigger a little bit. It's easier to break a bit if you go faster. And so we're going to tap this hole again. And then we'll do the same thing with all of them. And like a bigger drill bit, a bigger tap, I've seen people run them in with a drill before. I don't like doing it because, like I said, it is possible to build up aluminum in the threads and break it off back in and out. Like I think I showed it in the frame video that I had one broke off, and I just kind of threaded that one in a little bit too far before turning it back to kind of break the fresh cut aluminum from the threads and this little slot here. There's 4 slots. And so after you get one in each corner, it's probably good to drill. I do like to overkill and put 3 or 4 in. It's nice and firm. I'm gonna drill. Let me see. This is the back. And when you drill, notice I got an arrow here and here. I'm gonna drill, I guess, just this one for now, because this is gonna go in the machine like this. And I'm gonna measure from here to there, and then this will be removed when we're doing it. Oh, I'll have to pick that up before I have a mess, but that'll end up getting a screw bolt hole there, and then this will be used as a template. Like I said, I'll be uploading a 3D printable version of that in case you don't have one. It's already drawn, so it's not going to be that big of a deal. And also, the holes and the bed screws are M4s. You probably already have them if you have a reality bed and you took apart a machine, but they got to be tapered head M4s. Not sure what the thread size is because M4 is kind of a size I use the least of. And then for the nuts on them going through the bed is just the wheels that adjust, on an end of 3. And that hole that we're going to drill here, I'm going to drill it initially with a M4 or 4mm bit. Creality went a tiny bit bigger than 4mm, but it's under 4.5. So I'll have to crunch some math on a quick little break and figure out what that is. I think I used an American size. But you can get away with 4.5mm. That doesn't have to be really tight because bushings are going to come up against it. It's going to have a fair amount of traction. And if it's too tight, when you tilt like this, them holes are going to bind on the threads. It's going to be hard to level the bed. So it does have to have a little bit of slop for that hole and the other 3. But okay, so I'm going to drill the rest of these off camera, and when I switch the bit, I'll drill this one. We'll blow everything off, and then we're going to do whatever tracing we're going to do, and we're going to pull these plates and then do the rest of the work without the plates there. I like to, when I drill this hole, I do like to save my plates, know which end's what, because I do like to kind of like sometimes set them on just for reference before I go boring, just to kind of make sure it looks right, And so that's basically the gist of it. I'm going to pause the video and poke those holes. Okay, and, we are back. So, I drilled all the holes on the ends here on both sides, tapped them all. Like I said, you can use nuts. And then I got, 2 here, 2 here. Same thing down here. And I'm going to take my Sharpie now, because I like to have as many guide points as I can. I'm going to double check the camera positioning. So it's white on white. I didn't really think about this before I did the video. Should have printed this a different color so this stuff doesn't blend. But the big hole for the bearing, we're going to kind of lean at an angle. We're going to trace tight to the outside. I like to go around a bunch of times. It's okay if you make a wide line there. The key is making sure that outer edge is covered, all 3 holes. Same thing on the other end. Basically, we want that line as tight to the plastic as we can get it, because this is going to help us stay true to center. And you may find that you don't need them. I kind of don't like to leave stuff to chance. So, I don't know, I guess because this stuff's gonna peel off, you could trace these too, for just in case you want to double check and you get a better reference point on dropping it on exactly where it was when he's and tight to the plastic. And if you didn't have a coated sheet, this kind of marker will come off even days later with a little bit of I don't know if it's 98% alcohol, 99, something like that. Just put a little on a paper towel and you rub it and it'll wipe right off. So now we don't need, well, actually, I guess I'm going to poke one hole. I'll probably mark this hole. It's just kind of that's the one we're not going to poke. There's no sense to mark these. They're not going to be there in the final thing tomorrow. I'm just going to poke one of them because I'm real fussy and I want to make sure that I'm not skewed before I poke the other. And I'll probably poke those with it up in the machine. I'll lower the bed. I don't put a lot of pressure when I drill aluminum because more pressure, you get a bite, it hangs up. That's a small drill bit, it's going to snap. So, yes, let's get rid of these vice grips. There. Let's pull these screws. We're gonna pull the, before I pull the screw, I gotta drill that one hole, don't it? And you always want to do it in the back, not the front, them holes you're gonna drill. And it's because we want to make sure we're at a factory distance, or it's not really a factory, but at the right distance so that the end stop can adjust into the range that it needs to. So if you were to drill these on the front and then use the template, you might be too far this way, and so that's an important key factor. And that's only because it's a sliding jig. If it was a solid, and we might be able to just drill them all and forget about it. So try to be somewhat straight this way, somewhat straight that way. That was with an M4 bit. I'm going to take a bed screw. Just see. Okay, we got a little wiggle. That should be sufficient. If you're worried about it, like jump up, you don't want to jump up a millimeter. Half a millimeter is probably max, but if it was me, I don't have Google available right now. I believe 4 millimeter is it 3/16? I think so. I'm not sure. I'll have to look it up. But so I got that one hole drilled. We're gonna lose the plates now. do a little bit of measuring and ruler work for a center on the 3 holes on each end of the plate. The center is important to get as dead knot as you can, because, you know, it's like if you're off a little this way and off a little that way, then they'll shift a little bit, but not as much as you'd hope. And I actually am using 3Ms so that they can shift a little bit further. Like if you poke these with 3.5 millimeter drill bit, you can thread them to 4M and it will fit the bearing. But you may find that you wish you didn't, just due to the fact you can get just a smidgen more movement. When they're tight, they're not going to go anywhere anyway. I've been running my real under 5 for almost 3 years with 3Ms in the front. They've never loosened up, never had a problem. And so you don't want to rub real hard where you did your marker lines, because this is some weird material, and well, I guess it's not smudging there, but like these darker lines, I've had them smudge. So I guess I wish I had a ruler for a straight edge. Basically, I'm going to use that fine tip marker and a ruler is probably more ideal for this. Let me make sure we're somewhat in focus here. Kind of stinks that this is white too. Wonder if I got something else. Okay. I guess this is orange. So what I like to do is just kind of I guess I'll pull the camera down so I can give you guys a better look. So the idea is we need a set of crosshairs so we can center punch this. And we want them to be somewhat accurate. So what I like to do is take a straight edge. We're going to try to get just about half hole on, and then we're going to draw our line. Then we're going to turn it, do the same thing here, 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 and the same over there. And then we'll have, in the end, 6X, marks for center, 1 for each hole. And then we'll be double checking to make sure it looks centered with the naked eye too. If it doesn't look centered with the naked eye, then it's probably really off center. And again, the fine tip marker, not the one that makes the wide lines. And make sure you get a nice transfer tight to the plastic. Guess that could come out a little darker. My marker is very, very old. You can run it past these. In fact, it's probably better that you do, because then you can judge, like, if you were a little off center, you can tell easier if you run it past straight to the holes, and then you'll be less likely to make a mistake that you will regret later. Fast. We're about half full. On the center ones, it might be easier to use an actual square. And this might end up being a two-part video because I think it's pushing midnight. I mean, I'm gonna go as long as I can, because like I said, I want this printer done. And you know, sometimes you have unexpected family things that slow you down, like an hour here and an hour there. You plan on doing something at a certain time, you kind of discover that you're going to do it 3 hours later than planned, kind of thing, or and I'm running them by right to the holes so I can get a good look when I'm done. Kind of like how these are coated, because even though you can wash them off somewhat easily, it's better to be able to just peel it. So now we're going to do a close-up. I have one that I can see that I don't like. That's why we do it this way. So we got a set of crosshairs there. We're kind of looking at our holes. That isn't quite perfect. It's probably pretty close. That edge is a little bit more, so I'll probably kind of redraw that line, make it a little tiny bit wider. But basically, you can see how you can kind of use those lines and them holes to tell if you're where you want to be. And then when you like it, we're going to use a center punch and a hammer, and we're just going to make a little divot where each one of the X's, like crosshairs, meet. So I'm going to put this back in the camera holder because I need two hands. So which one was it that I didn't really like? I guess that one looks good. This one I could stand the twig just a little bit. And I don't even know if it's gonna. I guess it didn't really change much. So, I mean, when you're there, you're close. It's not gonna make much of a difference. So I guess I'm pretty happy with that. When you center punch these, you kind of want the whole thing flat on the bench. It's better if, what did I do with my cap? Yeah, right there. It's better if you're kind of right up over it, eyeballing it rather than being out here. And you don't need a heavy hammer. So basically, I'm gonna look at all my holes, see if I like it, and then I always kind of hold it at an angle. They actually make spring-loaded ones of these that are really nice, but when you're happy with where you are, you got a little divot, I guess, a little tiny bit out. And it's just so your drill bit doesn't walk, it kind of guides it. Guess I like that one alright. And then this one here. Now if you're off like a little tiny bit, I can show you a way to center that hole without So if you punch it and then you move it over like this a tiny bit and you punch it again because you didn't like where it was, it's probably not going to go as smooth as you want it to, just because the punches will be real close together. And so that one, get a little look here. Guess I like that. And so we got all 6 of them set up. Like I said, you just kind of need a pilot hole. It's no real set size. I mean, if you got American bits, I like to start sometimes with an 1/8. And then I jump up. Like on aluminum, you don't want to just go one size because it's going to bite and drill so fast. And if it's a small bit, it's going to break it. So I like to kind of like, say I was doing metric, I might do like 3mm for a pilot hole. And then I might jump to like 5 or 6, you know, like 2 or 3mm at a time till I get to the size I want. And you know, overhang my bench a little bit. And then this is another reason why we put labels, is because even though it looks good, just going to kind of line up all my marks, kind of see what I think. That looks pretty good. Pretty sure the back will kind of look the same, or I guess, yeah, this would be the back because I have it spun 180. You can get a more accurate look if you put the screws back in, but if you're looking down through the holes, you can see all the threads, and yeah, it's going to be close enough. So, what do I got in this? I think a 4M. We might as well start with that, I guess. Back, yeah, I guess. You want to try to go straight down through if you can. And it's this pilot hole that's the most important location. The smaller the bit you start with, the better, because it's easier to get it in that little divot. And and get you a little more centered. And so it's like I'm doing it the lazy way. I've done a lot of these. Maybe not this exact plate, a lot of them, but I've done a lot of similar projects. And okay. You should be wearing eye protection. I mean, I got glasses here somewhere. I don't really know where they are, so this is the one that my prick was a little off, so I'm going to walk that way just a little, and then I'm going to straighten my bit. And drill it down through. And another little secret is these holes are not quite, or I should say the bearings are not quite 19. I'll walk that way a little. So if you wear off a little tiny bit, it's not going to be the end of the world as long as it's not very much. So we got pilot holes, so, oh, I missed one on the lead screw on this end. So you're going to drill all the pilots first, because otherwise you're going to change your bit a whole bunch of times. And so we got all of our pilot holes. Basically, we're going to jump up and up until we hit the size. We want to drill them till the line's gone. And just before the line's gone, I like to take what's going in the hole, you know, dust it off, and just kind of find out what I got going on, if I'm close or if I'm not. That way, you know, I don't take too much, but that's my burn here. So I wanted to measure these for the video. And, okay, so close these up, make sure they're 0. This is just a cheap Harbor Freight deal. So these are like basically 18.9495. I've been using a 3/4 drill bit, which is pretty much 19 millimeter. It's, or, you know, its closest equivalency. So you can use either one to poke the big holes. And excuse me. So our lead screws, those are 9.85, so you're going to drill those 10 millimeter if you get a 10 millimeter bit. Trying to think of what that is in 30 seconds. I can't remember off the top of my head, and I usually Google with my phone. I'll put it in a little note with in the file section. I want to say, let me see, 3/8 would be 6/16. So it's going to be in 30 seconds, I think. I'll figure it out and I'll put it in a little note. But somewhere I got a 10 millimeter that I'll be. We're not going to hit the 10 millimeter right on the next drill. We're going to jump I did 4, so I got a 6 and a 6.5. I'm gonna jump to 6. Poke, poke, poke. Same up there. We're gonna work our way up. Probably don't have to do every size, you know. Just know you're gonna jump up a couple millimeters. When you get close, I kind of jump up less, and just run the drill a little slower, and because it's gonna cut like butter. It's pretty much cutting like butter now. And that's basically the gist. After all of it's drilled, we're gonna flip it over. There'll probably be a few burrs where we run the tap down through. Just gonna clean up what we can. Technically, you can get away without cleaning it up at all, especially if you don't put nuts under here and you tap it like I did. But I'm kind of about looks a little bit too, and you know, I just want it to look good. And you know, after it's all drilled and we hit our sizes and it's cleaned up, I'm gonna kind of lift up the corners and then just cut the corners out so I can drop my bearings in, and I can leave this because I got my one hole here, and I'm gonna use the template after I put it in, get it where I want it, and you know, I'm gonna run a bolt right down through this original hole, and then I'm gonna measure. This will be spun, and I'll measure from basically the center of this hole to this inner edge. Get it the same here. Tighten that down as good as I can. I'll probably use my little vice grip and scrap trick just so I don't scratch the heck out of stuff and it doesn't shift, and just poke the rest of the holes, and we're only going to be poking the 4, and then we'll have our bed mounts and our skew will be right, and then we'll be able to peel the plastic. I don't bother to cut this stuff out. Technically the Ender 5 is set up a lot different than what this is, even though they look very similar. Like this is the back and the top and the bottom, and see how it's mounted right direct to that back rail. Well, on an Ender 5 we have another 2020 sticking out. Now they do this because they got pre-drilled holes and the spacing. They don't want you to have to deal with it. So you actually lose a little bit of travel. It's done on the top and the bottom. And that was one of the things I didn't like about the Ender 5, is because, you know, what if I want to put a Hermit the Crab on this son of a gun, or, you know, dual 50-15 fans or something, and the frame's already too small in an Ender 5. I mean, you can get the full distance, but you got to really play with the end stops, and you know, I just didn't like that. And but so I'm gonna pause the video, and then we'll go from there. I hope I got this whole video. It seems like less minutes than I expected, but alright, so we'll be back in a bit. Okay, and we are back. So I used the 10mm drill bit for the final hole here. And it's just barely got a little bit bigger. Just a slight amount of wiggle and movement. That's what you're looking for. And then the drill bit that I use, like, see how we got a little bit of give here? We're looking for that, and there's a reason why. It's because we're not using a CNC. which when I make the ones to sell, I will be using a CNC, so these will be all computer cut with the end mills, and the only thing that'll be done by hand is the threading itself, and that's just because it's so intricate. Like if it was a big hole and it was deep, I might consider doing it a different way, but a lot of this Razzie looking is just this coating. It actually doesn't feel like there's much protruding down underneath. So basically at this point, I got a bunch of metal shavings. I gotta clean stuff up. I'm gonna be, I don't know if I can get a hold of that. I'm gonna be just lifting my edges so that I can drop a bearing in. I like to take a little small, either half round file or a round file, just kind of kiss the edges, which is something that when it's CNC'd we won't have to worry about that. And looking down in, and everything's looking real nice. All my bolt holes still look good. So basically I'll just be cleaning up a little bit off camera. I'm gonna bolt all these on. We're gonna leave them so they can wiggle, so we can get them back on these over here and get these up into place. Drop it down to the bottom. I'll end up lifting it up. We won't put the leads in immediately. Or actually, maybe I will, because it'll help hold it up here on this top rail close so I can measure. And then not only that, but we're actually going to square this or tram it with these two top rails. And that's why I decided to put that in instead of doing it the way I did the last time on the tensioner, because we're going to thread the rods till everything's touching. We're going to back them off 1/8 of an inch, and then we're going to lift it up so we got like 1/8 of an inch clearance in there, or like, a couple millimeters. And then we're going to tighten them with it touching here, both sides. And where it's belted, it'll stay in alignment, and then we just screw it down a little bit so that we can assemble the rest of the axes, and that'll be the end of the axis when we get to that point. But alright, so I'm going to pause the video again and just kind of get my plate ready to, I'm sure you guys know how these are going in, and I'm sure I showed this before, but I'll show it this way too. So that tall one's a stock end of 5. If you use single Z, you have to use these, and I don't recommend it because this thing over here was single Z, and right out of the box I had problems with the front of the bed sagging, and it was like you could adjust it, get a print in, but then it would sag different amounts every time you homed it, and so on. And so I figured, these are mounted straight up and down like that. There's less bearings in there, but we're going to lubricate that before we put it together so it runs smoothly. And I haven't had a problem running the shorter bearings at all. And in fact, I think I get better prints than I do with the real end of 5. And that's a pretty tricked out end of 5. But, it could be more tricked out. But alright, so I'm going to pause the video and I'll be back in just a little bit. Okay, and we're back. I dropped all these in. As you can see, I left them so they can wiggle a little bit. Did this intentionally. All of them are the same. Or, as same can get. And I'm going to put my camera back on the mount. I wish I had a quick clip instead of a zip tie. But so we're up on the mount. We're going to put this on those rails. It's pretty straightforward. So I got this turned back, so this is the front. They're more flush. And the back, they're less flush because I chose to put the excess for the leeway on the plus or minus on the cuts. So we're just going to kind of start to in fact, let me drip a little bit of one in those bearings. And we're just going to kind of wiggle them, let them line up. And we'll drop down on. Now, as you can see, I can barely move those now. I can move them a little bit. And we're going to bring these up into the mounts again. And a little bit of twist and lift. Bring them up till they're flush, or pretty much flush. A little bit more slippery with oil. That was that one that was fun to get in the other day. There we go. I also, when I cut these linear rods, I like to put the cut end down because then it looks cleaner. So we want all four of these in position. I like to kind of just check the travel. I like to go up and down a few times just to kind of make sure I'm liking it. And we're down all the way. So we're gonna tighten. Is it this one? No, it's this one. So we're gonna tighten these linear bearings. In fact, they probably should have gone in a crisscross pattern, but I don't think it'll make a huge difference. But I'll do that from here on out, though. I like to do this a little bit each time I tighten one, just because then I know if I picked up any bind where I'm picking it up at. You won't hear that noise with it running. Even the stock N5 makes that noise. It's got a bunch of little roller bearings. And when these linear rods are new, they're just kind of funkily cheap feeling, I guess. They're not really as good as linear rails, but you'd need a lot more components to run linear rails because they have to mount to something. and they mount, you know, like, I think I showed one the other day, but they got a bunch of holes going the whole length of it, and no, got many lines, so that's good. Tighten up this last one. So sometimes you have to do some more than one. It's actually seeming to come out of it after I move it a little bit, but I still want to try to get it a little bit better. Just tighten to it first. Whoops. Okay. That feels quite a bit better. And like I said, they will break in. They'll get smoother. Plus, you don't hear that with the way it moves on the printer. So we got two. These are 400s. Basically, we're gonna start them into the hole. And it will kind of somewhat lift with just one, but it'll have a tendency to kind of tilt a little. But the tilt we're going to take care of in a few minutes here. I may even find it easier to hold up on it some. Just thread these. I don't have these brass nuts all the way tight. So we're just threading these in. We want to have this somewhat close to the top. Stop there for now. Catch this one up. Always fun threading something close to 400 millimeters. You know, fingers get tired after a little while. So my thought here, I'm going to pull this back a little bit, not real back because I kind of want it to put some max on still. But we're going to run these up till the linear bearings touch on both sides, and then we're going to back them off about the same amount. And guess it come out just a little bit. The Z never goes this high when you're actually printing. Get that restarted. There we go. So what we're going to have to do in this case, because I hadn't tried this idea before, we're going to need something the same height, just like a little spacer to go in each one. You can also do this with measuring in the center here, in the center there. The idea is there's a shaft in here, and we want a little space in between the two shafts. We'll have a little bit less vibration, but we want this to be kind of trimmed with the frame, or like really close, because if it's tilted a bunch, you'll still build a level, but you might get a little behind. And I just got a bunch of these. It's not really. So what I'm going to do is, these are all the same height. I'll just drop them down so I can just kind of fit a set in there. Just enough so it's just touching. Goes the same way. Okay. Actually, I guess I'm going to measure. It'll be more accurate, because it's possible these can be jiggled up or down a little bit. So the idea is, in fact, I just noticed my leads are slightly different lengths, and I bought them at the same place. Go figure. Okay. So let's make sure it was zeroed out. So I'm at 4. So I guess what I'm going to do on the first one, in the front, if I can get it to go here. Oh. Okay. Make sure, in fact, I guess I gotta loosen it just a little bit. Figure out which one it is. Alright. So I haven't bottomed inside this thing. So I'm just going to tighten this one right up. Get back in the... Okay. And then from here, so I'm going to go down a little more. Okay, I'm just bottomed in that one. So now we want to know the measurement front and back. It's with 395. We're going to want to be the same or close. I mean, wait a minute. 395. $39.55. So we're a little bit low over here. That probably be a good idea to do it this center. And you're not going to be able to probably perfectly get it exact, but you kind of want to be close. It just kind of ensures it's not going to bind that much. And then we're going to tighten up that screw, and then we'll double check, make sure we didn't slip any. Or at least, if we did, a very small amount is acceptable. Like I said, the closer you get it, the less likely you are to have any kind of Z binding. And then, so now we got both of them linked. I like to turn them a little bit, just kind of make sure they're going free still, and they are. And so that's the whole Z together, this together. Obviously we got to mount the bed. So what I'm going to do, I'm hoping that this will go as high as that's about as high as I can safely go. Pick that up. We got our hole. I'm low battery, so I'm gonna have to stop the video in a minute. So here's our template. Doesn't really matter which way it goes. The holes are all the same distance. I'm gonna drop it on here. We're gonna take one of our bed screws. I don't have any 4M nuts kicking around, so T-nut works fine. It's only a temp just to kind of hold it. Gonna drop that right down through the hole that we drilled, the singular one. We're going to start that T-nut on, thread it up to the plate. This will just kind of help us to know that we're not skewed any. And that's a tapered bolt, so I'm just going to get it what looks close by the eye. And I'm debating, do I want to use the tape? I mean, technically, probably not, but it's probably what I got that's going to work the best. So just about 4/4. care if I scratch this gantry. It's probably, well, I mean the Ender 3 one, it's probably never ever going to be used again for anything but a drill template. But I don't want to scratch my new plate, so I'm going to want to double check this because I think I just moved a tiny bit. Yeah. So I'm not like cranking right on it to hold it either. That's just over quarter. That's, so I'm going to tweak that just a little. Okay, I'm liking that. Liking that. There's probably more precision way of measuring that, but it's what I got and what I can do. Now, it's a Phillips screw. Let's see. Oh, I don't have a Phillips screwdriver right here. I'm not going to crank it right tight. I just want to kind of make sure that that bed bolt's going to do its job. And then I'm going to double check my measurement one more time. Make sure it doesn't move. Looking good there. Looking good there. So that was my 4 bit, which is, gotta double check that actually was bigger. I may have put it in a weird spot. Oh, forgetting about my, so basically, I'm gonna just drill these holes. If I can find my bit that I had just a little bit ago, right there, phew. And I'm gonna go in an Xing pattern. Like I said, I'm not gonna apply a lot of pressure. Better to drill slow and steady than it is to abuse. So we're going to take, should have another M4 here. We're going to drop that down through. Basically you'll stick another T-nut on them real low on battery, so let's just pretend I stuck the T-nut on. I'm going to do it off camera anyway. We're going to double check again. I'm good there. I'm good there. So with that tight, you can poke this hole, pull them out, peel the material, and then clean up any little burrs, and then you're ready for the bed. And I like to use these. You can use springs. I haven't actually built one of these with springs. I have a bunch of springs. And then after that point, we're going to be on to the Y-axis and the X. And this pretty much wraps up this video. You guys know how I'm going to drill the other 2 holes, and I'm probably going to test fit the bed, and then I'm probably going to pull it back off just so I don't bang anything up by accident doing X or Y. And it's basically the X-axis and the bed gantry. And the next video we're probably going to do, I guess we're going to do Y first, and then we'll do X. And alright, so I'll probably be making that video sometime tomorrow. I'll upload them all and whatnot. And I guess that's it for now. Hope everybody's getting this. If you get any questions, feel free to ask.